So let us check with some more example of basis path testing. Okay, so here is some example, some program by which we will calculate the factorial of some number. Okay, so in this program actually you have one main program and then you have some other component like the function to calculate the factorial. Okay, so this is one portion and this is another portion. So in this program of calculating factorial, it consists of a main function and a module fact, which is actually going to calculate the factorial. So how to calculate the cyclomatic complexity of this kind of things? Up to previous class, we learned how to calculate cyclomatic complexity for a single graph. Okay, where p's value is 1. Now you have two different part in the same program. So how you are going to calculate the cyclomatic complexity? So the basic principle is, if a program P consists of multiple component X, Y, and Z, then you prepare the flow graph, that means control flow graph for DD graph for P and for each component X, Y, and Z. Then the complexity number of the whole program is summation of all parts. Okay, you will calculate the complexity for each part, each portion, and then you add those together to get the final cyclomatic complexity of that graph or of that program. Okay, so we will see this example. For this example, if you draw the graph, it will be like this. Okay, so this is for the if condition. So if it is true, then we will execute this statement and we will go to the end. And if it is not the case, in that case we enter into the else. So when you enter into the else, you will find this new function fact. So for this you have a different portion of code base. So for this code you are actually drawing some other graph where this is the decision point, this is the for loop. So it will continue for some times, and after exiting from the for loop you will go to this step where you will actually return the product, that is the result, and this result you will send it to this else part, and finally you will get the result. So the graph will be like this, and you will have two portion of this graph. One is for the main and another one is for the fact. Okay, up to this, is it clear? Okay, let's move to the next slide. So now we have the graph. So according to our principle, we need to calculate the cyclomatic complexity of these two portions separately, one for this one and another for this one. And after finding the complexity of these two, we will add those together to get the final complexity of this program. So if you calculate the complexity of the main function, in that case you will find the complexity like this. We actually figure out the complexity using the three formulas that we learned in last lecture. So we have three different formula to calculate the complexity. We apply each of them and we find the same result every time. Okay, so similarly you will find the complexity for the factorial function, and for this fact function you will also get the same results, similar result for all three formulas. So now you have the cyclomatic complexity for this main function is 2 and this main function is 2. So overall this complexity will be 4. Okay, now if you want to find the complexity of this whole graph at a time, that is also possible. Okay, so next slide we will observe that. So we have this graph. So if you consider this is a whole graph, in that case, what is the value of P? Previously, we worked only with a single portion. So P's value was 1. Now P's value is 2. This one is 1 for P. This one is 1 for P. So when you calculate cyclomatic complexity for the whole graph, in that case, your P's value is 2 because you have one here, one here. Okay, so and if you see number of edges 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges you have, 9 vertex you have, and P's value is 2. So you get the complexity as 4. If you think about decision point, so P's value is 2, and how many decision point you have? There is one decision point, here is another decision point. So you have two decision points. So 2, and why it is 2? Because here this value is 1 because you have two outgoing link. When you have exactly two outgoing link, the D's value will be 1. So here you will find 1, and here is also exactly two outgoing link. So value is 1. So you are getting 1 plus 1 2. So D's value is 2 and P's value is 2. So you are getting 4. And the number of region is 4. So which is actually the number of region is the main function in the factorial function. Okay. So what we observe that if you calculate the complexity using the whole graph, the value you will find the same value if you measure the complexity separately using the different components of the graph. So the thing is why you actually calculate using the components, using the different parts of the graph. Because if the graph is very complex, if it is a very large graph with 100 nodes or 50 nodes, in that case it will be very difficult to calculate the edges and nodes for the whole graph. So whether you can choose only a portion of the graph and you can calculate the complexity of that portion, and then next portion, then next portion, then next portion, how many component you have, you calculate separately complexity separately for each component, and then you add those up to get the final complexity of your program. So here are some applications for basis path testing. So with basis path testing, you actually testing all sort of paths. So you are confirming the full coverage of the code, and uh, in some cases during maintenance, you modify the source code. So after modification, definitely there can be new paths. So with path testing, you can discover those paths and you can actually confirm those. And unit testing, you already know that unit in your lab, you are actually practicing the unit testing, and while you are writing unit testing, you are actually test the program or modules themselves, and um, you are actually testing the paths, different branches you are testing with unit testing. Integration testing, while you are integrating different modules, you may discover various kind of interface issue. So that are actually existence of different path from module to module. So you can apply basis path testing while in integration testing. In that case, you will be able to discover all the independent paths and you can apply test cases for all of those. So nothing will be missed. And testing effort, as you are calculating the complexity of the cyclomatic complexity of your program, so which is actually the complexity of your software. So if you know the complexity of software, you can actually easily estimate the effort you need to put to design the test cases for your software or your program. So now we will move to graph matrices. So this is another technique for white box testing. So this is actually composed of graph matrix and connection matrix. Two types of matrix are there. So one is graph matrix, one is connection matrix. These are very simple things. You already know that if you already have the course discrete math. So these are the same concept from the graph theory. So graph matrix is something, this is square matrix where rows and columns are equal to the number of nodes in the control flow graph or DD graph. So how you are going to describe a graph matrix? So each cell in the matrix can be a direct connection or link between one node to another. So if there is a direct connection exists between two nodes, then the entry for that cell will be the name of that edge. Okay, so if there is a connection from A to B, then it doesn't mean that there is a connection from B to A, because this is a directed graph. In that case, A to B doesn't mean B to A. So it will always uh, uh, you will always say the connection is from A to B, not from B to A, because this is a directed graph. And conventionally, we represent graph matrix. Digits are used for nodes and letter symbol for edges or connections. That means for nodes you use some number, and for the edges we use some alphabet. So this is some convention. You can choose anything. So there is no hard and fast rule. So this is an example. This is a graph. Okay, so you have 1 2 3 4 nodes and 5 edges, A B C D E. So if I ask you to draw the graph matrix, what will be the size of the matrix? Can anyone tell me? Anyone? Can you hear me? Hello.
জি স্যার।
জি স্যার।
So here
হ্যাঁ স্যার, মানে বৃষ্টির জন্য ভয়েস অনেক কেটে কেটে আসছে স্যার।
জি স্যার,
নেটওয়ার্ক প্রবলেম।
নেটওয়ার্কটা খুব খারাপ স্যার।
so can you hear me now clearly?
ইয়েস স্যার।
জি
So
স্যার।
the thing is, we have 4 nodes. So if you want to develop the graph matrix, what will be the size of that matrix? Can anyone tell me? Okay, if you have 4 nodes, that means there will be 4 row and 4 columns. So what will be those? For example, 1. So this will be the matrix. Okay. So what will be the values? So we say if we have a connection between one node to another node, then only that cell will have some value. Okay. For example, if you want to traverse from 1 to 1, is there any path? Yes, there is a path A. So it will be A. So 1 to 2, is there any directed path? Okay, this is path B. So it will be B. 1 to 3, it C. 1 to 4, there is no direct connection. Okay, so it will be empty. Then for 2, from 2 we can only traverse to 4, and the link is D. And from 3 we can traverse only 4. So this is E. And all other, and from 4 we cannot go to any other node. So all the cells will be empty. So this will be the actually graph matrix for this given graph. So here is it. And we have another graph, another example. So if we prepare the graph matrix for this one, it will be something like that. And okay, why here is A plus B? Because from 1 you can traverse 2 using 2 different link. One is A, one is B. So that's why it is written 1 plus B, A plus B. Okay. So up to this, is it clear? So this is very simple thing, preparing the graph matrix from a graph. So you can be able to develop graph matrix from any given graph easily. Okay. So next, we will know a different thing. That means you may be interested to find k-link path from one node to another. That is, from node 1 to node 3, how many paths exist which use actually exactly 2 edges. If we say 2 link path, if we say 3 link path from 1 to 3, then it means that you want to find some path from node 1 to node 3 which will contain exactly 3 different edges. Okay, so how we figure out this? We figure out this by the power operation of matrix. That means matrix multiplication you need to know. So if you want to figure out two link paths, in that case you need to multiply the original matrix with the same matrix. And if you want to figure out the 3 link matrix, you need to multiply the matrix 3 times. If you need to want to figure out 4 links path, in that case you need to multiply the matrix 4 times. Okay, so we will see some example. Here is our matrix. Okay, graph matrix. So if you want to, so for example we want to find 2 link paths for each node. So I hope every one of you are familiar with matrix multiplication, right? Matrix multiplication জানেন?
जी सर
Yes, sir.
Okay. So in that
Yes, sir.
case, just normal multiplication. If you multiply these two matrices, the resultant matrix will be like this. Okay. So here A square, here BD plus C. What does it means? We will see in the next slide. Okay. So okay. Next slide. We will not find that. So what was our graph? 1, 2, 3, 4. So like A, this one B, this one C, this one D, this one E. So we are saying that we are finding two links path. That means in this resultant matrix, the values are something like that, where from a source to destination, the links shows will contain exactly two paths, two edges. Okay. So if you see from 1 to 1, so 1, 2, 3, 4, 1, 2, 3, 4. So if you want to move from 1 to 1 with two link path, then you need to traverse this path twice. Okay, then you will move to 1 using two edges. Okay, what about if you want to move from 1 to 2? 1 to 2, if you want to move using two edges, that means two links. In that case, you have to traverse A first, one link, one edge, then 1 to 2 using B. So AB. That means you are traversing two edges, two edge path to reach at the destination 2. Same for C3, node 3, 1 to node 3. You need to traverse A and then you need to traverse C. Now, if you want to traverse 1 to 4, 1 to 4, what will happen? Okay, so 1 to 4, what will happen? 1 to 4, you can go either using BD and or you can go through C and E, right? So in that case, you have two different paths to traverse from 1 to node 4, which will have exactly two different edges. So those are BD and C. So you can move to node 4 from 1 using two different path, and every path has exactly two edges, BD and C. Okay, so দুইটা করে এজ আছে প্রত্যেকটা পাথের মধ্যে, এবং দুইটা পাথে আমরা রিচ করতে পারি, যে কারণে এই দুইটাকে প্লাস দিয়ে এখানে রিপ্রেজেন্ট করা হয়েছে। ওকে, এন্ড সি from 2 to 2, from node 2 to node 2 অথবা node 2 থেকে node 3 তে যেতে, there is no path which will have two link. Even previously you can see one link এর path ছিল আপনার 2 থেকে 4 এ যাওয়ার, there was a path which was D, right? Now when we are trying to calculate a two link path for 2 and 4, you will not find anyone. Okay, because there doesn't exist any path with two link for 2 and 4. Just a minute. So it starts raining at my place. Okay, so do you understand? Is it clear? আপনাকে যদি দুই লিঙ্কের পাথ বের করতে বলা হয়, you will just multiply the original matrix 2 times. Okay, so multiply original matrix with the same one, then the resultant matrix will have the entries for two links path. So এখানে দেখেন যে 2 থেকে 4 এ একটা পাথ ছিল D, which is a single link path, but যখন আমরা ক্যালকুলেট করলাম টু লিঙ্ক পাথ তখন দেখেন যে এই এন্ট্রিটা 0 হয়ে গেছে, বিকজ এই গ্রাফের মধ্যে কোনো টু লিঙ্ক পাথ নাই যেটা দিয়ে ইউ ক্যান ট্রাভার্স ফ্রম 2 to 4. ওকে, সো এই ম্যাট্রিক্সে যদি আপনারা ইফ ইউ ওয়ান্ট টু ফিগার আউট থ্রি লিঙ্ক পাথ যদি বের করতে চান, দেখেন 1 থেকে 4 এ যাওয়ার জন্য থ্রি লিঙ্ক পাথ একটা আছে। প্রথমে এ ইউজ করবেন, দেন বি ইউজ করবেন, দেন ডি ইউজ করবেন। যদি 4 লিঙ্ক পাথ বের করতে বলেন সেই ক্ষেত্রে আপনি হয়তো এ কে দুইবার ইউজ করবেন, বি ইউজ করবেন, ডি ইউজ করবেন, বাট অন্য এন্ট্রির জন্য ইউ মে নট ফাইন্ড এনি entries. Okay, so let us see another example. So here is a graph. So we want to derive graph matrix and find two link and three link set of path. So the matrix will be like this. Okay, so এটা তো আপনারা জেনারেট করতে পারবেন, right? You will be able to generate this one. Am I right?
जी सर।
जी सर।
This is just simply 1 2 3 4 1 2 3 4. So node to node, if there is any connection, no connection, then 0. If there is any connection, then write the name of that edge. If there is two connection, then plus that connection you have to write. Okay, so if you want to figure out two link paths, then just multiply the original matrix with the same one, and you will, the resultant matrix will contain the entries of two link paths. So here you can see BD from 1 to, this is 2, 1 to 2, there is a path B and D. So if you see 1 to 2, if you want to, so B and D, so these two is used to go from 1 to 2. Previously it was only 1 to 2, it was only A, that means single link path, you will use only this one. But if you want to traverse from 1 to 2 using two link path, then you will traverse in this way. Similarly for others, and for if you want to traverse from 1 to 4, how you can traverse? AE. So this one and this one, this is two link, one link, so two link AE othoba BF. So you just sum up this. So now if you try to figure out the three link path, so this one is the two link path, so multiply this one with the original matrix, or you can multiply this one, this one, this one serially. So এই তিনটাকে মাল্টিপ্লাই করলেও you will generate the same result, or you can multiply the result of two link with the original one, then the resultant matrix will contain the entries of three link path from one node to another. So for example, if you check this one from 1 to 4, what is the three link path? One is BDE, so you can see BDE. So this is the path to go from 1 to 4. Another one is ACF. Okay, so in this way you can find the K-link set of paths from a graph matrix. So now we will start with connection matrix. So this is very simple. If you have previously your entry was the edge name, but if you have some connection, you will just put 1 in that cell, otherwise the entry will be 0. Okay, so it is a 0 1 matrix. So if we see some example, so here is the same graph. So if you calculate the connection matrix, it will be something like that. This 1 means 1 to 1 there is a connection. This 1 means 1 to 2 there is some connection. 1 to 3 there is some connection. 2 to 4 there is some connection. So 2 to 4 there is some connection. 3 to 4 there is some connection. So that's why these entries are 1. Otherwise, and all others will be 0. Okay. So This is connection matrix. So if you want to draw connection matrix for this one, what will be? It will be like this. So 1 to 2, 1 to 2, there is connection. There is exactly two connection. Previously we wrote it as A plus B, right? But now we will just put weight 1 if any connection exists. If there is multiple connection exists, no matter, you will just put 1 in that entry. So 1 to 3 there is a connection, so you put 1, and 3 to 4 there is a connection, 3 to 4, so you put 1. So all other entries are empty. Okay, so this is connection matrix. So why we develop connection matrix? So there are some importance of connection matrix. From connection matrix we can actually calculate the cyclomatic complexity very easily. So how? So there are a few steps. First one is, for each row count the number of ones and write it in front of the row, then subtract 1 from that number, then sum of those number and add 1 with that result, and the result you found in the step 4 is the cyclomatic complexity. So if we see some example, that will be clear. So you have a graph like this, right? So this is the, up to this is the connection matrix. So according to our rule, what we need to do, for each row we have to calculate this number first. So that means number of ones. Here is 3, here is 1, here is 1. So here is no one. So you don't need to worry about that. And then from this number you have to subtract 1. So from each row you subtract 1. So this is the result. So you are going to add all this. So adding all this resulting this one 2, and with the result you will add 1. This one add 1 and the result is 3. So the complexity is 3. So now if you try to calculate the complexity using some other formula you already know, you can calculate and find the same result. For example, if you want to calculate the result with decision point, for example, you have, we studied some formula like this, V of G equal to D plus P, right? এটাই তো cyclomatic complexity calculate করার formula. So what is the value of D here? Can anyone say? D এর ভ্যালু কত? Okay, P এর value 1, you can easily say, because there is only one graph. Okay, so P's value is 1. So what is the value of D? So how to calculate the value of D? কেউ বলতে পারেন? So roll 16 আছেন? Roll number 16. কি 16 নাই? 16 প্রেজেন্ট না? Can you hear me? শুনতে পাচ্ছেন? হ্যালো, 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 can you guys hear me?
জি স্যার।
Yes,
এত
sir.
কথা বলেন না কেন? So roll 16 আছেন? Roll 16 কি available? So who is roll number 16? Let me check.
আসসালামু আলাইকুম স্যার।
বলেন।
স্যার আমি ওয়াশরুমে গিয়েছিলাম একটু।
Okay, so বলেন এই গ্রাফ থেকে how we can calculate the d, what will be the value of d? So do you know how to calculate the value of d?
জি না স্যার।
Okay, last class we studied how to calculate the value of d. So if there is exactly two outgoing link, in that case d's value is 1. If there is more than two outgoing link, in that case d's value is k minus 1. So k is the number of outgoing links. So here the outgoing link is 1 2 3, right? Ekta duita tinta, so 3 minus 1, so d's value is 2. So the cyclomatic complexity is 3. So this is exactly same as the cyclomatic complexity you calculated using the connection matrix. So now you find the 4 different ways to calculate cyclomatic complexity. So what are those? One is using the adjacent node, and another one is using the decision point, another one is using the number of region, another one is using the cyclomatic complexity. Okay, is it clear?
জি স্যার।
Okay, so here you can see we have some other example for this graph. So cyclomatic complexity here is you find this number first 2 and 1, then subtract 1, then you will find these results, add these two, so this will produce this one, and add 1 with this one, and the final result is 2. So the cyclomatic complexity is 2. So if you want to find the cyclomatic complexity using the formula which uses number of nodes and number of edges, so what will be the result? Okay, so how many edges are there? কয়টা edge আছে এই গ্রাফে? So we have 4 edges here. How many nodes are there?
চারটা।
Okay, minus 4 plus 2 into p. So this one was one formula, right? That is e minus p plus 2p. Okay, so what is the value of p?
1 স্যার।
1. So that means 0 plus 2. So it will be 2. So this is same as this one. Okay, so cyclomatic complexity you can easily calculate using the using what? So what are the 4 different way to calculate cyclomatic complexity? চারটা কি কি ওয়ে আছে একটু বলেন আমাকে, আমি একটু আগেই বলছি। Number 1,
Sir, ages.
edges বলেন। So first one, you can calculate the cyclomatic complexity using number of edge and number of nodes. So using this formula, you can calculate the cyclomatic. Secondly, you can calculate the cyclomatic complexity using the number of decision point. Okay. Thirdly, you can calculate the cyclomatic complexity using the number of region present in a graph. Fourthly, you can calculate the cyclomatic complexity from the connection matrix. Okay, connection matrix. So there are 4 different ways can be utilized to calculate the cyclomatic complexity. So now we start with loop testing. So আপনারা একটা গ্রুপ ল্যাবে অলরেডি লুপ টেস্টিং দেখার কথা ইউনিট টেস্টিং এ, রাইট?
জি
Most
স্যার।
probably 1A. So we will just cover few things here, few theories here, because already you will have the lab in the during sessional. So what actually we do in loop testing? So what is the objective? We want to figure out the presence of any infinite loop. যে আপনার ভুলবশত কোনো ইনফাইনাইট লুপিং আছে কিনা, we can figure out those using loop testing. We want to know the performance of the loop, that means whether it is required to optimize the loop or not. So if there is any initialization problem, we can figure out those. We can also figure out the uninitialized variables inside the loop. We can also figure those out. So we will take some example. So what are the different kinds of loop? So চার ধরনের loop we normally encounter during our coding. So one is simple loop, next one is nested loop, and then it is called concatenated loop, and next one is unstructured loop. Okay, so আপনারা এই চারটা সম্পর্কে জানেন? Do you know what are those? So what is a loop? Loop এর definition বলেন আমাকে একটু।
লাস্টের দুইটা
স্যার কোনো ক্লোজ পাথ
কন্টিনিউটেড লুপ আর
ওকে, লুপ হচ্ছে এমন একটা জিনিস, সো যদি বাই ডেফিনিশন আমরা যদি বলি, লুপ হচ্ছে সামথিং দ্যাট execute some instruction continuously or repeat for sometimes until it reaches the condition, given condition. কোন একটা given condition এ পৌঁছানোর আগ পর্যন্ত those instruction will be repeated. সেটাকে আমরা লুপ বলতেছি। Is it clear? খুব সিম্পল বাংলায় বললে এইটাই হয় যে আমাদের কিছু ইনস্ট্রাকশন আছে যেটাকে আমরা রিপিট করব আনটিল আমাদের কোন একটা গিভেন কন্ডিশন মিট করা পর্যন্ত। সো আমরা তো লুপের জন্য প্রথমে কোন একটা কন্ডিশন লিখি, তাই না? দেন উই রাইট সাম ইনস্ট্রাকশন, যে ওই কন্ডিশনগুলো মিট করলে আমরা হচ্ছে লুপের মধ্যে ঢুকি, দেন উই এক্সিকিউট দ্য ইনস্ট্রাকশন, এন্ড যতক্ষণ পর্যন্ত ওই কন্ডিশনটা মিট করে ততক্ষণ পর্যন্ত উই রিপিট দোজ ইনস্ট্রাকশন। ওয়ান্স দ্য কন্ডিশন ফলস, উই exit from that loop. So there are four kinds of loop: simple loop, nested loop, concatenated, and unstructured. We will check each of those. Okay, so simple loop is normal for or while or do while loop, so you already know those. So let's see some examples. So this is a simple loop. So here is a loop. So here will be some repetition based on the condition. So how we are going to calculate? We are going to write the test cases, or we are going to test this loop. So first we will write some test cases. That test case, our intention will be to skip this loop. আমরা এমন একটা টেস্ট কেস লিখবো যেটা দিয়ে এই লুপটাকে স্কিপ করে আমরা অন্য টেস্ট কেসগুলোকে এক্সিকিউট করতে, অন্য পোরশনগুলোকে এক্সিকিউট করতে পারি। Then we will make some test case that will pass through the loop at least once. একবার লুপটা কন্টিনিউ করবে এইরকম কোনো ভ্যালু দিয়ে আমরা চেক করব। Then we will test the loop for 2 times 2 pass, যে দুইবার এই লুপটা চলবে এরকম কোনো ভ্যালু দিয়ে we will test this loop. Then we will choose some random number in between the mean and max. Okay, so loop condition যে ম্যাক্সিমাম ভ্যালু থাকবে সেই ম্যাক্সিমাম ভ্যালু ম্যাক্সিমাম মানে ওই লুপটা ম্যাক্সিমাম কত সংখ্যক বার চলবে, that must be defined. So ওই ডেফিনিশন থেকে less than that we will choose some number. For example, if your max number is 100 times, so if you decided to run a loop for 100 times, so that means you can try with 60, you can try with 50. So এমন কিছু টেস্ট কেস লিখবো যেটা হচ্ছে এই লুপটাকে 50 বার বা 60 বার এক্সিকিউট করবে, and we will check the result of that iteration, so whether they are producing the right result or not. Also we need to make some test cases for the maximum iteration and maximum -1 and maximum +1. Okay, so এই সবগুলা টেস্ট যদি we can perform, then we can confirm okay loop testing is done for a simple loop. ওকে, সো এই জিনিস আপনাদেরকে ল্যাবে আপনারা প্র্যাকটিস করছেন হয়তো অ্যাসার্ট অ্যাপ্লাই করে, রাইট? ল্যাবে করা হয়েছে?
স্যার প্র্যাকটিস করা হয় পড়ানো
ম্যাম এক্সাম্পল
Okay, so you can write some simple for loop and you can just practice it. তো
জি
সেটা
স্যার
যে ইউনিট দিয়ে করতে পারেন, এনি ইউনিট দিয়ে করুন, যে কোনোটা দিয়ে করতে পারেন। ওকে, so nested loop. What is a nested loop? This is something loop inside a loop. একটা লুপের মধ্যে আরেকটা লুপ যখন থাকবে তখনই we will call it a nested loop. So there may be nested loop. So একটার মধ্যে এরকম মাল্টিপল লুপ থাকতে পারে, so those we call nested loop. So there's a simple example of nested loop. So this is the outer loop and this is the inner loop. Okay, so this is a example of nested loop. So how you are going to test the nested loop? So you will start with this inner loop. You will start this inner loop first and consider this one as a simple loop because this inner loop is a simple loop, right? So এটাকে একটা simple loop চিন্তা করে এই simple loop এর যেসব testing you will perform for this loop first, and once this one is tested then you go to the outer side. Okay, then consider this one as a simple loop and apply all the tests for this loop, and if there is any more then you go to that loop and consider this one as a simple loop and apply simple loop testing. So this is how we are going to test nested loop. So a nested loop starts with the innermost loop, and for the innermost loop conduct the simple loop test, work outward and continue until the outermost loop has been tested. So that's what I told just few minutes back. So concatenated loops are the loops after the loop. মানে একটা loop শেষ হওয়ার পরে you have another loop. So it may happen you may have several loops one after another. So those we will call concatenated loops. So let's see some example. Here are two loops one after another. Okay. So how you are going to test those? Simply, if the loops are independent, যদি লুপগুলো independent হয়, then treat them as a simple loop and test one after another. Okay. Unstructured loops are the combination of nested and concatenated loop. So it is basically a group of loops that are in no order. এই লুপগুলোর কোনো order নাই. So those who are not good coder, they normally write this sort of coding. So for example, this is one loop, this is one loop, this is one loop, this is one loop. So many loops are there and one is from another one. Some portion of loop is inside in another loop. So this is very complex scenario. Okay, so how you are going to test this unstructured loop? Do you have any idea? So এই ধরনের কেস
স্যার আনস্ট্রাকচার্ড লুপ,
বুঝি নাই,
স্যার আনস্ট্রাকচার্ড লুপ মানে এটা
বলেন।
স্যার লুপটা স্যার মানে এটা কিভাবে পসিবল স্যার? একটা লুপ থেকে আরেকটা থেকে মানে এই একটা বুঝি নাই স্যার। এই হচ্ছে আপনার ফ্লো চার্টটা স্যার।
This is
যে
okay, এটা this is a wrong one. This is a wrong one. Okay, আরেকটু গেলে বুঝতে পারবেন। So unstructured loop is a bug. Okay, so এই unstructured looping আসলে আপনি যখন লিখতেছেন আপনার কোড আসলে এক্সিকিউশনে গিয়ে it will produce wrong result, even it will not execute because আপনি আসলে যেসব নোভিস কোডার they don't know about looping properly, they use this sort of wrong implementation and they actually produce some unstructured loop. So যখনই এই ধরনের প্রডিউস করবে তখন আসলে এটাকে আমি টেস্ট কিভাবে করব, এই জন্য আমি প্রশ্নটা করছি how you are going to test this unstructured loop. So আপনি যখনই টেস্ট করতে যাবেন, আপনি যখনই এটাকে একটা সিম্পল লুপ আকারে টেস্ট করতে যাবেন তখনই you will discover this is an unstructured loop and there is no way to check these unstructured loops other than redesign that one. So আপনি যখনই এরকম কমপ্লেক্স সিচুয়েশন পাবেন, code is not running, not working because of some unstructured programming. So what you are going to do, you will not perform the test, you will redesign. আপনি এই লুপগুলোকে ব্রেক করবেন, ব্রেক করে আপনি নতুন করে আবার এই লুপগুলোকে লিখবেন, then you will be able to write. মেবি এইগুলোকে আপনি রিস্ট্রাকচার যখন করবেন এখানে হয়তো দুইটা নেস্টেড লুপ হবে, একটা সিম্পল লুপ হবে, মেবি এখানে 5টা কনক্যাটেনেটেড লুপ হবে। ক্লিয়ার?
জি স্যার।
So from next class we will start with data flow testing, and then we will have mutation testing. Okay, so do you have any question?